Probably.
That'd be nice.
Okay, so she is running with 9.37 meters per second, and she's going to jump over this river.
This river, the Jordan River.
You know, she could jump a lot farther if she jumped up too.
Oh, she's,
Oh yeah. Oh.
that would, you'd have to use the quadratic if you did that.
She'd be this projectile.
9.37. And what is that variable?
That is apparently that's
VX.
VXI. But VXI and VXF is equal to, is the same, right?
They don't change.
They don't change. If the difference in height between the two banks is 2 meters, so actually
How'd you put a river?
it's like this would be.
Drive your Honda into the river because the Honda's got the built edge.
How wide is the river? So they want to know what. So what'd you do?
Well,
Make a triangle.
well.
Right, find time. Because Vx is equal to x over t.
Yeah.
We need to find x. We know Vx, but we need to find t. So now we're going to use our y equations. Which equation?
I can't even follow my own work.
At squared. Because initial in the y is 0. Because there is a vi y t part that comes before this, but that is 0, so we just leave it out. So delta y is -2 equal to 1/2. What's a?
Negative 9.8.
And then t squared. So t is what? 0.639 seconds. Now we can plug that in here. So we have Vx is 9.37 equals x over 0.639.
I don't know how you guys got that.
So it's 5.98.
That's good.
You know that you made that look so easy. I probably took like half an hour on that problem.
5.98. Okay, that was good.
That was good. Number one.
I'm lost. I don't know how to do it.
Where do you get lost, Jack?
Right after you tell the stick guy. Looks like he's peeing.
Okay, well, we know, we start with this equation because they're asking for x, and that's the only equation with x in it. It's the only equation that has x.
Yeah.
Okay, so when you look at the variables, we only know.
Are all those equations in the notes for this chapter again?
Yep, well, you can use all the same equations.
Are they in the notes?
Oh, they aren't probably in this chapter's notes. You probably have to go back to chapter 2.
Okay.
Okay, so you've got our formula, right?
Okay, so then we know we have to find time. That's one thing that we could find using all of our y information. So now you look at all your equations, and we know VIY.
Y is 2.
Yep, and our change in y is right here. We know VIY, and we know A.
Negative.
Because going down.
Because delta y is equal to VF minus VI. What's our initial, or our final y distance is 0. Our initial is 2. So it's actually 0 minus 2. That's why we get a -2. And our negative 9.8. So that way the negatives cancel.
I thought it's originally 9.
It's always negative because it's downward.
Well, I'm always, that's free fall. It's 9.8 though.
Yeah.
Because you're going down. So
Always go down.
Uh-huh.
That's why it's negative.
And the down the direction is negative.
Fall up too?
No.
No.
It's
I
always
follow
negative
upstairs.
9.8.
It's never 9.8. That's just what people say.
Okay, well, I've been lied to my whole life.
hot air balloon.
Good thing we got that straightened out now.
Hot air balloons fall.
Okay.
Next, 4.
Yes.
Yeah, it's cool.
Elmer Tret.
What's the answer?
Were the two ramps at the same height?
0.7 big one. That's what I got.
I got 0.78.
0.7.
It's a horizontal ramp. No, they weren't the same. So it's a horizontal ramp. So it's just like these problems where you have this distance and he lands.
Isn't it the same? I thought he was.
No, it's not an angled ramp. It's not a ramp like that.
Oh, that's what I thought.
No.
It says it's a horizontal ramp.
I drew it.
Yeah.
horizontal.
Okay, so
Okay.
bike. There's a guy riding it.
It's like a scooter. I'd like to see him go 360.
The answer is 0.735 meters.
Oh, we gotta do it then, 'cause I got 0.784.
I was 0.001 on.
Nah, do it. Nobody got it right.
No one got it right. Do it.
Okay.
Softball players may be excused.
What do we got? We know X is 40 meters.
That thousandth meter just failed me.
Oh, this is when we have to convert units.
Yep. So we have to change 372.
Birding on top of this.
Yeah, I know.
Whoops. We need to change that into meters per second, which is, what is it? What number? Someone who converted it.
103.3 meters per second.
Okay.
0.3
I did not.
repeating.
I don't get that. But whatever. When you're
So-
doing a little chart thing,
Yep.
is it kilometers and then over,
Yeah, the kilometers and the H is under.
and then you do 1 kilometer?
It would be
1,000.
372.
Okay.
So that is going to be VX, right?
Yes.
Are we gonna have to like draw that on a test? Because I don't understand how to do it that way.
What?
Yeah.
The conversion.
This?
Crap, that
No.
stuff, yeah.
I just do.
That's fine. Yep. VX. We know this, and they want to know how high, right? They're looking for Y.
How high?
How high is the ramp?
Yes.
Height of the ramp. This time we know Vx, x, so we can solve for t. That's how we're going to solve for t, not using y. So t is equal to x over Vx, right?
Oh yeah.
Everyone knows that equation? So we have 40.0 over what's that time?
Time.
0.38.
387.
Okay. Now, we need y. So we need y in our equation, we need t in our equation, and what's initial velocity in the y? Zero.
Is it always 0?
Yep, for these kind of problems. So
Only horizontal.
we can probably use that same equation where delta y is equal to 1/2 a
Summation.
t squared. Now, I'm going to just write this that way. This really is VIYT plus 1/2 AT squared. That's the whole equation.
But you don't get that.
But this part, VIY, is 0, so that's 0. We drop it out. That's why.
That's where that comes from. Finally got to come on now.
1/2, okay, this is negative 9.8 times 0.387 squared. That's still the wrong answer?
I put up my calculator and got 7.34.
That's what I'm got.
7.34?
Or
0.734.
Oh, that's because they substitute this whole thing into t. We didn't do that. We rounded. This number's rounded. This number's even rounded. So we have a little bit of difference in rounding. Yeah, this would be fine.
That's good, 'cause that's what I got. I thought you would fail.
No.
Or even 0.75.
0.75? Well, how did you round different? Did you not?
Well, it's 103.3 repeatedly.
I'd look at your work. I'd look at your work, and if everything was right, it was just rounded different, then I would be okay.
Time I rounded up to 0.3.
That could maybe change it that much. Yeah. Good?
Yeah.
7?
Yeah.
You never round.
Yeah, just keep. Write it all out. It's starting to make sense now. It does. I wonder if
So he throws the basketball. He's at the top of his head. Okay. That'd be a weird, I guess he'd have to like throw it this way.
Yeah, you know what? Instead of trying to figure out, just throw it out. I was thinking, the initial speed, why can't it be 0? Because he didn't throw it until.
Whoa, who we drawing there?
I don't know. He's throwing the ball though.
No, it's
The ball comes, actually, hold on.
He's got a tumor. You can draw 2 sets of arms, so it's a guy on top of another guy.
How the initial speed was only 0.
He's throwing the ball.
Yeah, why can't the initial speed just be 0?
Circle Y. He's holding.
No. In the Y direction. In the Y direction.
Now
So VIY is equal to 0. What's the answer?
I can withdraw half.
9.77, please.
9.8.
So we need to find.
You didn't throw it from his face. Ball goes on the go.
And then does it tell us what VX is?
No. Or find it.
Oh, that's what we're trying to
No,
find.
it's height.
We know its height is 2 something. What was it? 2.
2.45 meters.
Okay. Is that all we know? Oh, the end speed?
Well, obviously,
This is where it
acceleration.
messes me up.
This
That's
is,
our
okay,
fault.
so this speed right here is 12 meters per second. Okay, this is one that's a little tricky. I like
Why
it.
you don't
I mean, technically our answer should be 12, but
Other than that.
because it's not.
No,
It doesn't
BX,
slow down at all.
right.
It was this problem that made you rethink
No,
my
it speeds up. How?
Actually, it's probably
Because it's speeding up as it goes down.
But it's covering less distance horizontally.
No, it covers the same every time horizontally because it never speeds up and it doesn't slow down.
Yeah.
The horizontal distance it covers
It
each
has to
seconds is the
speed
same.
up in order to cover the same distance horizontally. If it was going down as well.
There's an 8 that you're getting back. Your
It's
acceleration.
Yeah, it does speed up. That's what she's saying.
It would have
It does not speed up
No,
in the X.
he's
The
talking-
vertical,
Yeah,
yes.
vertical speeds up in order for it to
No, the horizontal would have to speed up.
No.
Yes. Because that's why a hypotenuse is longer than going straight down. It's the same thing. Going in this direction is longer.
Oh my goodness.
No, you can just.
Okay, so Vx is equal to 12 times the cosine of theta, correct? And then this is, oops, Vyf. So the final y is 12 times the sine of theta.
Now why
How do
is
you know
that?
theta?
What the?
We don't know theta.
Explain to me the sine and cosine of this stuff. Why
Because we're looking at this angle.
you're finding that
So
Right.
sine is opposite of a hypotenuse.
So then I multiply the hypotenuse over. So really it's
So toe it doesn't
cosine of theta equals x
Where's the 2.45?
over 12, but then I multiply 12 over to get this.
Oh, okay.
That make sense?
Where's the 2.45 coming to play?
Where's the what?
2.45 meters.
Oh, I don't even, do you even need it? I don't know.
We
We need to find theta.
What is theta?
So.
Let's write equations that we know. We know Vx is equal to x over t. That doesn't really help us because we'll have a theta here and we don't know x. We don't know time. We don't know anything in that equation. So let's try a y equation. What do we know? We know a, we know VIY, and we know y. What equation do we have that would have VYF, VIY,
The 1/2 thing.
as long as it has VF in it? We really have all the other variables. So I used this one.
That should do it.
But you probably could use this one. Nope, we don't know T.
So we pay need that.
For this test that we'll take when we drive on the way, we can see smaller ones.
I would give you this equation, but have dx right here, and you just have to know you have to change it for the y parts.
Wait, what? Okay, so we do need that.
We do need what?
Define time. You can
No, we don't need time. But what would be another one we could use? We could use delta y is equal to.
1/2 a squared.
No, that has time in it.
Why?
Let's just use the one that's up there.
That's fine. Yeah.
So that's the only one.
Oh. T squared. We don't want that one.
That's
Okay.
we defined t squared.
But you don't need it. So VFY. VIY is 0, right? Get rid of that. VFY, we said, is 12 sine theta. 2 times A is 9.8, negative 9.8. Y is negative 2.45. Oh, I forgot. This is squared, right? Now, instead of squaring 12 and taking sine squared theta, I don't know if you can do that. I would take the square root of everything. So you'd have 12 sine theta 2 times negative 9.8 times negative 2.45. Okay, and then solve for theta. So theta, you're going to end up having to take the inverse sine. So this is divide by 12. And then you take the inverse sine of all that. $35.5. How do we have a difference if none of this is rounded? We shouldn't have a difference.
Maybe it's just the calculator's rounded.
How did they do it? Oh, somehow they use Pythagorean theorem.
How do they do that?
I don't know. I like our way. Is it 5 or 3? 3. Okay. Okay. Now, since we have theta, we could plug that in up here. So now Vx, which is what we're looking for, is equal to 12 times the cosine of 35.3. And what is that? Should be 9.8. Yeah? I was just making sure we were right. Is that
Yeah, I like that.
okay? Good. Next. What one?
Time for more. Do it, please. Do number 6. That's the only one I don't understand.
Oh yeah, we did do number 1 yesterday, didn't we?
Yesterday, and I still couldn't figure it out.
So we had to do 1. Yeah, number 1 and number 3 should be just like.
That's the only reason I got number 3.
Okay, so let's do number 6.
So what you had to do 1, 3, and 6. Is that it for this?
I could figure 6 was the only one I knew how to do.
6 was the only one I didn't know how to do.
6.
was really easy.
You should have 60 degrees.
I have 59.3.
I had
That's
60
close
degrees only because I found it on the internet.
No, it's really, it took me about two things to do.
Yeah. 6
All you
was
do is
easy.
draw the triangle and then find the angle.
Yeah, that's all you have to do.
Yeah.
I do have the two sides already.
You just gotta take the tangent of the angle. Yeah.
Where did you get the
Okay, so this is
You're like a 5-year-old.
number 6. 18, an average speed of 5. Holy cow. It's a ball forward at twice his running speed and catches it at the same level. At what angle?
He throws at twice the speed.
Yeah.
So it really is a, that's really small.
But how do you get the? What do you have for the side again?
Whoa.
You have adjacent, you have hypotenuse.
No, I had two sides.
Where'd you get 9.8?
Yeah, you have adjacent side and you have
Yeah,
hypotenuse.
how'd you get 9.8?
That's gravity.
So,
Throws a ball up forward, twice his running distance.
Where's she doing it for?
So what his running distance, his running speed is 5.82, so it's twice that.
So that
Right
means
here.
DIY is always 9.8 because you drew it, so it's.
A is y 9.8. Acceleration is 9.8. What 5.82 times 2 is 10.64. I'm gonna draw this equation because what it wants the angle.
I did it different.
How do you find the angle?
9.8 is
And that's
gravity.
all we know? Oh, we know.
You know, he throws it.
Your y is 9.8 because of gravity.
No, that's A. A is equal to
Well, I
negative
used
9.8.
and it worked for me. So.
You don't need to find it.
Yeah.
You have time.
You're trying to find x. So
You have time.
change of x
We don't have time.
vi
18.9.
cosine of theta.
But that's just how fast he ran it. 110 meters. That's not what he's doing here. That's just to find that average speed.
Oh, I can't. So that's because Vx is equal to cosine of theta, or Vi times the cosine of theta.
And then you have your time.
So this is times t. But the time, you don't have time. Yeah, but isn't that time? That's for the whole race. That's not how long the ball is in the air. Why 2?
Or you don't even have to just use it that way.
And you can use gravity for your y.
So apparently you can do whatever. and it works.
Yeah, pretty much.
I don't think you can use 18.9.
I use gravity. It works well.
What's your X?
Because the ball wouldn't be in the air the whole time he's running 110 meters.
Wait, doesn't the final velocity have to be 5.82 because he has to catch it at his speed?
Wouldn't your X be 5.82?
No.
Your final,
Read the question
your final
again.
velocity
I can answer this.
has to be 5.82 because he has to catch it.
Yeah.
So
Right here?
Today's
This is 11.64 also.
Senior high student council meeting tomorrow.
Because he catches it at the same height.
I don't know, but
So
how
the
is he supposed to
speed-
keep up with
Deadline
the
to
ball if he's
register for the
on
October
5.82?
ACT test is Friday.
The ball's 11.64.
And remember seniors, the pizza party. because
That's
you
his
scored
average
above
speed.
the state average in state writing is tomorrow at 11:45 in the
No, but like
cafeteria.
the
And school is out at
horizontal.
noon tomorrow.
It's
and
not
there is
going
no
just
after-school
horizontal.
study.
Right.
I know, but
Oh, I get you. The Vx has to be 5.82. You're saying.
because he's going 5.82 and has to keep up with it.
Collections
Yeah,
for
and that's what I wrote down. And gravity is y, and you take the tangent.
are
bring
in,
it up.
and
Here, I'll
the
show you.
juniors have taken the lead with.
Got it. So-
$58, followed by the seniors,
Yes.
$20 under that with.
Because it says he runs at 5.82 and he's running it all in the x direction, so his speed correlates to the x speed of the ball.
Thanks, and have a great day.
His speed correlates to the speed of the ball. I wouldn't use tangent. I would use something with the hypotenuse, so I'd use cosine. So cosine of theta. That way we don't have to use the y. Is
The y works.
adjacent over hypotenuse. So then theta,
You're gonna get 60.
60.
He throws it up twice as fast as he's running, which is 11.
Should get 60.
60.
I would have probably looked at your work and then saw you did something a little off.
Can you tell us the answers for 3 and 8?
Yep. 3, 16.6, 8, is 3.2 centimeters.
Whoa.
8 is 3.2 centimeters. Oh, no, it says the maximum height. That's all it gives.
What is the magnitude of this horizontal displacement?
All it says is the flea's maximum height is 3.2.
Well, I got that wrong anyway.
Oh, there it is. 0.33 meters is the other is x.
Oh! Who got that?
Okay, let's pick some new problems.
On the same packet?
Yep.
I scribbled them all out.
same packet?
So I kept on reading them wrong.
Yeah, I scribbled it out because I look at it and then I start reading it. So when does this do Thursday?
Okay, for D,
I got it.
We're done. We are done.
you want to write these down.
I'll just get them from
2,
Yeah, number 2.
5, and 6.
Is that it?
And then on E,
No, you're done.
Dylan, I'm gonna put you tomorrow. Love you.
oh my goodness. 2, 3.
I already did 3.
Oh, you already did 3?
Oh, we can do 3 though.
On E?
Yeah.
Oh, okay. I thought that was on D. Oh, you did 1 and 4 on D, huh? 2. You did 6 already, right? 5 and 7, right? You didn't do either of those.
When's it due?
When's it due? How about Thursday?
We got
Thursday.
Thursday, so I'm-
So,